那如果没有问题的话，就来到。So we have another sample problem. I think, have you got the PDF of this problem? PDF, yes? Okay, good. And so we have, this is a typical problem in 3D equilibrium. So let's go through the question first. A 200 kg cylinder. Cylinder is this one. It's hung by means of two cables A, B, and AC, and then attached to the top of the vertical wall. A horizontal force P perpendicular to the wall holds the cylinder in the position shown. Determine the magnitude of P and tension in each cable. By means of two cables. I think, are there any words that you don't understand or you can't get the meaning? Attached to this. Okay. So I think this should be clear enough. Then of course, the key points in exam is what do we need to determine? Okay. Determine the magnitude of P and tension in each cable. Is that okay? So the problem is clear, and let's go on with the solution. And we have let TB and TC be the tensions in cables AB and AC respectively. Respectively means this one. Respectively means this one. It means TB is linked to cable AB and TC linked to cable AC. Okay, respectively means this one. Okay. And before we do calculations, what should we do? Because there is equilibrium, we need to calculate equilibrium. So what do we need to do before we do the calculations? We need to draw diagram. Okay? We need to draw a three-point diagram. For the three-point diagram, and every force has some relationship with A, so we have A here. How many forces do we have in this problem? 4. Okay. Although in the diagram, it seems that we have 3 forces, but we have the 4th one as the gravity or the weight of the cylinder. Okay. So we have 4 forces. Remember this. Okay. We know the magnitude of W. What is the magnitude of W? is because the mass of the cylinder is 200 kg, so we can write the weight of this cylinder is 200 kg F, or this value, 1962 newtons. Remember, in engineering courses, we always use 9.81. We don't use 10. Okay. We multiply the we do the conversion by 9.81. We change from kgf to n by 9.81, not 10. Okay. So this is our figure diagram. The next thing is we want to determine we want to price AB, TB, and TC in IJK vectors. But the problem is, of course, we don't know about the direction cosines. Yes, we don't know the direction cosines. But what do we know? We know the distance here. We know distance here. We know the distance here. We know this one, and this one. Oh. So we can write down AB and AC. AB is this one. So this one is XB minus XA. And this one is YB minus YA. Because we are going from A to B, so we have B minus A in all three directions. It's okay. And from these three, from the x-axis, y-axis, and z-axis components, x-axis, y-axis, and z-axis components, we have AB equals to 12.86 meter. We can do the similar thing for AC. I think I've given you the PDF, so let me go through quickly. And these are the values. So at least you know how do they come from. We need this because we need to know we need to get the direction cosines of these things. We need to get the direction cosines of TB and TC. So because TB goes through AB and TC goes through AC, so we are using our SOP to determine the direction cosines. Therefore, lambda AB equals to 1.2 over lambda AB equals to this one. And these are cosine theta x, cosine theta y, and cosine theta z. if you are not, if you forget why we do this, you can read the notes, page 15. Okay. Before I go on to the next page, one point about the English of fractions. Fraction is so. How should we say this fraction? Anybody know? Anybody know how to say this? So let me go through a easy fraction and a difficult one. This thing is I think I should write like this. And in the English, we say the thing up above first and then the one down under. So this one, we will say 2/5. Okay, and for in our problem, in our example problem, we will say 10 over 40.19. So now you know how I go through these fractions. By the way, and for these two, anybody know the English of these two terms? Let's begin with this one. And this is numerator. And the one down under is called denominator. I usually do it this way. The longer one is below and the shorter one is above. So it looks better. So, and denominator is the one below and the numerator is the one above. Is that okay? And for fractions, we have 1.2 over 14.19. This is 10 over 14.19. Okay. So I hope it will make my English a bit clearer. Okay. Any problem up to now? No, it's not that we go on with equilibrium. So to get the marks for equilibrium, and especially if you don't know what to do, you first write down this one first, and at least you won't get a 0, right? I told you this. And start from here, summation f equals to 0. And what do we have in summation of forces? How many forces do we have? We have 4 forces, right? Which 4? TB. What else? TB, PC, PC, P, and the base W. Okay? So at least you won't get a 0, right? Or at least you'll get some marks. And for because we have more than 2 forces, we do it in a table. And in this one, we have discussed this on page, which page? 11. So we have discussed it on page 11, and we do, and then we work out the rest. I think TB, TC, P, and W, and summation F equals to 0. We have four forces, right? For the 4 forces, we only know the magnitude of W. And for the other 3, these are unknown. And what do we know? We know the components of these forces. Then remember to put in the minus sign if needed. Remember to put in the negatives or minus sign if you need to do so. And for the rest, please do it. Please look at the PDF. You can look at the PDF, or you look at the you do it as your homework. So, and by equilibrium, because we have 3 forces, we have 3 equations, and it looks like that. As I think I've told you that there is something missing here in these equations. When you do your homework or do your quiz or examination, you should write something here before you write down the mathematics. What should we write it down? Here, for example, here. Summation fx equal to 0, very good. Summation fy equal to 0, and summation fc equal to 0. Write them down, please. then we will get TB equals to is 3. For these 3 equations, I write in this form because it is quicker to. This is the format. This is the form you put into the calculator. Of course, if you can do it by hand, then you can do it by hand. But if you can learn to do this on the calculator. Okay. So this is this is everything this is everything required on Thursday. Is that okay? So if you are okay with this, and if you cannot copy everything now, that you always have your I have given you the PDF of this problem, the PDF file of this these 2 pages, I think. And let's go on with chapter 3. Chapter 3, rigid bodies and equipment. So let's work on how should we begin? For let's write down what's the difference between chapter 2 and chapter 3. In chapter 2, we deal with points. Sorry. And let's take a look. Let's take a look back to back at page 18. So we have all the forces act on A, right? At 1 point, point A. Or we have another, and we have all forces acting on A or B. But in chapter 3, we want to deal with something more complicated, and we have force acting on rigid bodies. I will talk about this term in a minute. Rigid body in Chinese is this one. this in Chinese, but I will talk about what does it mean in the English. Let's a rigid body is let's write it down. Please write down first, and I will talk about its meaning and the common problem with your seniors. Here, the form is this one, and the external forces is this one. In chapter 3, in chapter 2, all forces act on one point. Okay, now in chapter 3, forces would act on a body which has a length in x, y, and z directions. Okay, we are not acting forces on a point. We are acting forces on a body, and but we are only talking about rigid bodies. Rigid bodies are bodies which do not deform under external forces. That means if you pull it, or if you push it, or if you twist it, or you put all other kinds of forces on it, that the shape would be the same. Okay, the shape would be the same. And in the past examinations, your senior sometimes will say, and when I ask them what a rigid body is, some of them would say, if they write in English, it's this one. In Chinese, it's this one. These are all wrong. Okay, we are talking about this one. Is that okay? If I ask you in exam or in the future what are rigid bodies, those rigid bodies do not deform. Okay, if you write it in Chinese, it is this one, not this one. Remember this. Okay. So we are talking about bodies or objects that if you have different forces acting on it, that the shape will be the same. Okay. So, but there is still a difference between force acting on points and force acting on rigid bodies. The thing is, if we act forces on points, then it will only move either x, y, and z direction. If we act forces on a body, it can move x direction, y direction, or z direction, and it can also rotate. Okay, in this direction, or this direction, or this direction. So the difference between chapter 2 and chapter 3 is this one. Is it clear? And we have another term called external force, and I will talk about external force after the break. So let me stop recording.